All right, guys. So we're going to get started with endocrine system part 2. So the first thing that I want to ask you guys is, how are we feeling about the material from last week? Everybody still feeling relatively okay with that? Cool, cool, cool. Cool, cool. So we don't have a whole lot left to cover of the endocrine system, but we do have to cover the male reproductive system today as well. So we're going to move on through the last remaining bits of the endocrine system. And we're going to begin with the next gland, which is the pineal gland. Now, most of you Portland crunchy hippies, you guys all know about the pineal gland, right? It's the third eye gland. It's associated with sleep. It calcifies as you age. I don't know much about the energetic aspects of the pineal gland, but I can talk about its endocrine function. And the main function of the pineal gland is to regulate your sleep-wake cycle through the release of a hormone called melatonin. And everybody knows, right? Melatonin for sleep, right? If you can't sleep, you pop a pill of melatonin, it'll put you right out. Well, that's true. The pineal gland is located at the rear part of the third ventricle of the brain. It's very, very near the geographical center of your brain. So it's very close to dead center. It produces a chief hormone, melatonin, which stimulates the hypothalamus. Melatonin influences your sleep-wake patterns, both in your circadian rhythms, right, your day-night cycles, as well as the seasonal cycles, right? So if your melatonin balance is thrown off, this can be associated with things like seasonal affective disorder, when people tend to get really depressed around the holidays as the days shorten and the hours of sunlight become less. You feel like you're wasting your life away because you're working sun up to sundown. So the release of melatonin is stimulated by darkness, and it is inhibited by light. So your melatonin levels are naturally supposed to decline in the morning. They remain low throughout the day. And then as evening sets in, your melatonin rates rise, which kind of coaxes you into a drowsy, sleepy state. Now, we've also discovered some other functions of this hormone. Mainly, it helps to regulate immune processes. So they've shown that melatonin does act on the production of cytokines from your immune cells, as well as hematopoiesis, so the production of blood, as well as the functions of immune cell target cell functions. So the way that immune cells will interact with other target cells. Melatonin receptors have been demonstrated, and their functions have been localized enough to justify an immune function assigned to that hormone. So we've got our circadian rhythm and seasonal rhythms, right? Day, night, sleep, wake, that's the main function. We also have immune function, and we also have some influence on sexual development, as well as the onset of puberty.
I have a question about the immune system function. Is that why they say that our body's like weakest around like midnight to 5 a.m.? Maybe why people pass away like early in the morning?
Why people pass away, I don't know. I don't know about that one, but here's what I can say. It's interesting you pull up a question about our sleep-wake cycles. So I've been reading a lot of things that suggest that our current 8-hour blocks of sleep is actually not the natural sleep pattern for humans. Especially when you read things from people hundreds of years ago, like the founding fathers and Renaissance people and things like that. Before really the advent of like electrical light, right? Using electricity for light. What a lot of people would do is they would fall asleep around 8 or 9 o'clock, and they would sleep for about 4 hours, and they would wake up around midnight or 1, and then they're awake in the middle of the night, and they would have this kind of productive time in the middle of the night, in the quiet and still of night when no one else is awake. This was a time usually spent for prayer, deep contemplation, meditation. People would also get a lot of writing done. A lot of like creative ideas would come to them. And then at about 4 or 5 in the morning, they would pack it up and they would go back to bed, and they would sleep for another 4 hours. This seems to be the more natural sleep pattern for us, is that we have 4-hour blocks of sleep that are separated by another 4-hour block of what's called liminal productivity, which is things like spiritual pursuits, creative pursuits, the kinds of things that the mind is better at when things are quiet and it can really focus without the distractions of things going on. But also that this really helps our brain kind of these 2 discrete sessions of sleep seemed to help our brain kind of consolidate memories. Long-term memories are encoded into long-term memory when you sleep. So your short-term memory is just like a short buffer for things. Things are really consolidated in your long-term memory during REM sleep. So if you're not getting proper REM sleep, you can have long-term memory issues. It's a relatively recent phenomenon that we start seeing humans sleeping in a single 8-hour block, or the way we see people being chronically sleep deprived. I mean, people running around 4 or 5 hours of sleep regularly. You know, it's not good for brain function. Let's just say you really do need sleep.
All right, and I have another question. And with the immune system, while we're sleeping, our body heals. Is that also what happens?
Yes. So when your body is sleeping, you're not expending a lot of energy on other things like muscle contractions or digestion, or you don't even have to breathe all that much, right? Since your activity level is so low, you don't need as much oxygen. So your respiration rate and heart rate will tend to lower. Now your body has all this energy, but we're not spending that money on anything. So we start rerouting our resources towards things like immune function. This is the time for things like memory consolidation. This is the time for muscles. Maybe they've been strained a little bit throughout the day, so muscles will repair and rebuild themselves. Sleeping is also a time for your neurons in your brain to go through and do their cleaning processes. Remember all those action potentials being spent around, they end up with calcium buildup and things like that. It's time for the neurons to purge themselves and clean themselves to make sure that the neural functions are at their best. Sleeping is a time for the body to rest and kind of recharge its batteries, repair the day-to-day micro damage that happens just from normal, living. And then, if there are major injuries, then we can really focus our healing attentions there while those calories are available for that. Because once you wake up and you start walking around, now we need those calories for digestion and muscle contraction and, actively paying attention to stuff. So yes. Good stuff. All right, good stuff. So we've got pineal gland. Its primary hormone is melatonin. Melatonin, we will say, circadian rhythm. So circadian is circa, meaning around, and dia meaning day. So your circadian is your around a day cycle. It's your normal 24-hour, your body's on a 24-hour biological clock. Circadian rhythm. Sexual development and the onset of puberty. And an immune function. So this graph just kind of summarizes what we were mentioning earlier about your day-night cycles. As morning comes in, your cortisol levels, right, the stimulant from your autonomic nervous system, the sympathetic division, cortisol stimulates the body in the morning. That wakes you up, gets you aroused. Those levels will drop consistently throughout the day. So we start to get more tired towards the evening. As night falls, right, and the light from the sun goes away, and we are currently in nighttime, now your melatonin levels will begin to rise. They will continue to rise for a few hours until they peak right around mid-morning, or I'm sorry, what's the word I'm looking for? Not midnight, but in the middle of the night. You know what I'm saying? Like the geographical center of the night, not 12 a.m. Towards the middle of your night cycle, those hormone levels will peak, and then they will begin to fall as you approach morning. And then again, when the next morning arises, your cortisol levels begin to rise. So again, we see a switching of the functions between a stress hormone, cortisol, and a relaxing, more parasympathetic division hormone. And these two will just kind of swap roles throughout the day. Again, homeostasis is always going to be maintained. The next gland we are going to look at is the pancreas. Pancreas is often called the largest endocrine gland. We also usually think about it more as a digestive organ, but it's really just a matter of how you really want to define it, right? We're really getting into semantics or splitting hairs here. The pancreas's job is to secrete two hormones. These hormones regulate your blood sugar. Now, blood sugar is related to digestion. So your blood sugar rises and falls based on the foods that you're eating. And insulin production is triggered during the intake of food. So as you eat, your blood sugar begins to rise, so we have to start releasing insulin. So does the organ function with the digestive system, or does it function as an endocrine gland? Well, it functions alongside the digestive system by releasing hormones. So it works with the digestive system by performing an endocrine function. So whether you want to categorize it as a digestive organ or an endocrine organ, either way, you're correct. It's really just a matter of how you want to parse this. How do you want to split hairs here? It really doesn't make a difference. The two hormones that we are chiefly being produced are insulin and glucagon. So there are two primary areas within the pancreas that are producing these hormones, and aptly enough, they are called alpha cells and beta cells. Your alpha cells produce glucagon, beta cells produce insulin. Beta cells are located within structures in the pancreas that are known as the islets of Langerhans. Islets, as in a small chain of islands, like small islands, islets. And Langerhans was the guy who discovered them. When in science, when you discover something, you get to name it, and most of us are really egotistical and we name it after ourselves. So the islets of Langerhans are these patches of beta cells within the pancreas. The beta cells produce insulin. Other areas are composed of alpha cells. Alpha cells produce glucagon. So these two also operate on one of these kind of feedback loop cycles, much like melatonin and cortisol. So as the levels of one increases, it causes the other to decrease, and vice versa. So insulin targets all of your body cells except for the brain and the liver and your kidneys. Brains have plenty of sugar readily available to them. They're good. But what insulin does is it enables your cells to absorb sugar that is in the blood. Your cells cannot just take in sugar on their own. It has to be bound to something in order to cross the membrane. So what it has to be bound with is insulin. When we bind sugar with insulin, it is able then to be taken within the cell membrane, and the cell can digest it and use it. But we can't get to the sugar without insulin. Otherwise, the sugar just floats in the bloodstream, right? So when your blood sugar levels are high, so blood sugar levels are high, triggers the release of insulin. Insulin helps to lower the blood sugar level by removing the sugar from the blood and inserting it into the cells. If this continues on, your blood sugar levels will return to normal. If your blood sugar levels continue to fall, then you will release glucagon. When your blood sugar levels are low, glucagon is released. Glucagon targets your liver cells to convert their stored glycogen into glucose, which just means we take the sugar out of a bottle and we dump the sugar itself into the bloodstream. So when we talk about what the liver is doing, we are converting a stored form of sugar into an active form of sugar. We then release the sugar into the bloodstream. Good stuff so far, guys? Any questions? Okie doke. Okay. Target blood sugar levels. I do not believe that we need to know this. I think this was just included for, I don't know. Massage therapists do not treat diabetes. We don't check people's blood sugars. We don't poke them with any needles to check their blood. So I'm at a loss as to why this is here other than just for educational purposes, but we don't need to know people's blood sugar levels. That's not a massage therapy function. But we do need to be aware of the condition of diabetes, because diabetes can have several contraindications for massage therapists. Now, diabetes comes in two types. There are type 1 and type 2. Type 1 diabetes is known as juvenile diabetes because it is more often diagnosed in childhood. This is something that we discover very early on in a child's life, that their pancreas is not producing enough insulin. Therefore, their blood sugar levels are not being regulated. They would have very high blood sugar. So what happens is their type 1 diabetics have to regularly monitor their blood sugar. You guys may have grown up with somebody with diabetes. You know, they have to carry this kit around with them. They have to prick their finger and put it on the paper and test the paper to see what their blood sugar is. And they would have to inject themselves with insulin as needed in order to regulate their blood sugar. So they're basically having to manually take on the function of their pancreas. The usual cause of this is the pancreas does not produce insulin. And it's very often an autoimmune cause. Usually the immune system is targeting the beta cells in the islets of Langerhans. When those cells are under immune attack, they cannot perform their normal functions. So as long as they're under attack by the immune system, they can't make insulin. So you don't have insulin. So your cells are not able to take the sugar in, it just stays in the blood. So their blood sugar levels get really, really high. This is where they have to inject themselves with insulin, which allows the cells to take in the sugar, lowering their blood sugar levels. We do not have a cure for this condition currently. The only thing that we can do is manage the symptoms, which involves daily multiple finger pricks and injections of insulin. Now, type 2 diabetes is often called adult onset diabetes. This is because it is more often diagnosed in adulthood, usually in the 40s and 50s. Type 2 diabetes is where the body isn't producing enough insulin or the body has become resistant to insulin. Now, this is usually diagnosed in adulthood because it is a disease that is associated with lifestyle. This is one where there is an extremely high correlation between type 2 diabetes and obesity and a sedentary lifestyle where they don't move a lot. They tend to stick on the couch or not really engage in a lot of exercise, and they consume way too many calories. So all of these excess calories get stored as fat. When your body consumes carbohydrates, sugars, your sugars are quick burning energy. Your cells are able to access and burn that energy immediately. But if those sugars are not burned quickly, then the excess calories will be stored as fat. Fat cannot be burned quickly. Fat requires a whole complex set of chemistry to happen before we can begin to burn fat. Your body will not invest in that chemistry as long as it has carbohydrates available to it. As long as we can burn the cheap energy, we will burn the cheap energy. We are not going to spend the money that it takes to mine some fat and digest that stuff. We will leave that stuff stored. So over the years, right, this doesn't happen when you eat one cheeseburger, right? Or you have one day where you eat a whole pizza by yourself. This is a lifestyle trend. As we continually consume too many calories, particularly carbohydrates, which spike your blood sugar because carbs are sugar, When your insulin levels continue to get spiked, your cells will begin to form a resistance, a tolerance to the insulin. Just like any drug that you put in your body, you will develop a tolerance to it, and it will take more and more of that drug to get you the same high. It will eventually require more and more insulin to stabilize your blood sugar levels because your cells become resistant to it. Over the years, the cells in your pancreas that are producing insulin become exhausted. They are literally working overtime, working so much harder than they normally have to do to accomplish the same level of blood sugar regulation. Eventually, they will become so exhausted that they will cease functioning, in which case type 2 diabetes hits its worst stride. Individuals with type 2 diabetes, it's full blown. They also have to monitor their blood sugar and take insulin. They are just having to take extra insulin above and beyond the base level that their bodies are naturally producing. This is the difference with type 1s, which is their body does not produce insulin at all, right? Because of the autoimmune attack, their body doesn't make it whatsoever. With type 2, their body is making it, but they're not making it enough because the cells have become so resistant to it. So they're having to take large quantities of insulin.
And that's why they say type 1 is so much more deadlier, because the body doesn't produce any insulin.
Because in kids, if you're not managing it for a child, they typically won't manage it for themselves. And blood sugar is one of those things where it can sneak up on you. Like by the time you realize your blood sugar is getting too low, if you don't get some candy or something, you get lightheaded, you get dizzy. You can fall. I mean, lots of stuff can happen. And then, of course, just having low blood sugar itself is really bad for the body. It's really not a good situation to be in. It affects the way that your brain is able to function. It affects the availability of energy to the rest of the body. I mean, all of your muscle cells, they all rely on sugar being readily available in the bloodstream. But they can't take in that sugar in the bloodstream without insulin. I'm just now getting around to looking up at the chat. Sorry, guys. Quick note about melatonin. Luke, yes. So again, we were talking about like kind of addiction, and the more, the longer you go, like the more and more insulin it will take to get the same fix, just like it takes more and more of the drug to get the same high. With your body producing natural hormones and then the person taking supplemental hormones, your body is not going to invest resources in things that you're providing for it. So if you're taking melatonin, then yeah, your pineal gland will stop producing melatonin. It doesn't have to, you're taking it. This will start to decrease the amount of melatonin that your body will naturally produce. So if you are taking melatonin for sleep, it's recommended that you take only as much as you need, only for a period of time. Usually they say no, don't take it any longer than a week. If you've been taking melatonin every day for a week, you got to give yourself a few weeks break from it to restore your natural melatonin production. Good point, Luke. Yeah, first sleep and second sleep is cool. Sugar in the blood makes the blood more acidic. That would be my understanding, yes. It is my understanding that sugar is more acidic. But I would just like to point out that insulin doesn't negate the sugar because the insulin is alkaline. It negates the acidity of the sugar because it physically removes the sugar from the blood by sequestering it within a cell. But we have to be bound to an insulin in order to pass through the cell membrane. Without it, the sugar just floats in the blood. The cells can't actually take it in unless it's bound to insulin. Cool. So there's type 1 and type 2 diabetes. Type 1, juvenile diabetes, typically an autoimmune disorder. Your body does not produce insulin. Type 2 diabetes is adult onset diabetes. There is a resistance to insulin, right? The insulin resistance requires you to take more insulin than your body naturally produces, and the amount that your body naturally produces may be reduced due to adrenal fatigue, or not adrenal fatigue, but endocrine fatigue. They're exhausted. Type 1 diabetes, there is no cure. You will be pricking your finger and taking insulin for the rest of your life. I'm very sorry about it, but that's the reality of your existence. Type 2 diabetes, on the other hand, is reversible. It is reversible. You do not have to just manage symptoms. You can reverse type 2 diabetes. It requires a lot of hard work and dedication and perseverance. It requires a strict dietary control and controlling what you're eating and how much you're eating, as well as getting on an exercise regimen to try to alter. Ultimately, what you're trying to do is to alter your fat to muscle ratio. And if you can get the BMI down to an acceptable level, then we can not only get rid of the fat, but we can also restore balance to your pancreas, and you don't have to take the insulin anymore. You can get yourself off of insulin with type 2 diabetes. Unfortunately, with type 1 diabetes, that's not an option. Type 1 diabetes, it's autoimmune. There's nothing we can do. All right, good stuff. All right, so now that we've talked about diabetes, the next topic on our list, the next pair of glands we're going to look at are ovaries and testes. So ovaries are the female only. These are female specific glands. They are located in the pelvis. The two primary hormones that are produced by the ovaries are estrogen and progesterone. So estrogen is produced in the ovaries. It is released by being stimulated by the presence of two other hormones. These are produced, we learned last week, in the anterior pituitary gland, the follicle stimulating hormone and the luteinizing hormone. When those two hormones are released into the bloodstream, the blood is eventually carried to the ovaries. The presence of those two hormones triggers the ovaries to release estrogen. Estrogen is involved in female sexual development, so the development of female sexual characteristics like the growth of breasts, as well as female sexual behavior. It regulates the menstrual cycle and pregnancy. Progesterone only influences the menstrual cycle and pregnancy. It loses the developmental function. It just regulates the monthly cycles and pregnancy, which hopefully is not monthly. It is released via stimulation of luteinizing hormone. So to see a representation, again, we're just kind of tracing hormone levels here. The first one that I would bring your attention to is the first graph. The pink line, you're looking at blood levels of luteinizing hormone. Luteinizing hormone triggers ovulation. So as the amount of that hormone rises, that triggers, if you go down to the next one, that triggers a fertile egg to be released from the follicle. That's the period. That's the whole reason we're doing this. We're trying to get this egg fertilized. Blood levels of estrogen, the teal colored line here, also rise, but once ovulation occurs, estrogen levels fall. They will slowly rise over the course of the next few weeks, but they do not rise as high as your luteinizing hormone levels do, and they will rise again later on. Whereas luteinizing hormone tends to stay low, it peaks to trigger ovulation, and then it settles itself back down. As these hormonal fluctuations occur, we also see a thickening of the uterine lining. So the portion of the menstrual cycle where the uterine lining begins to thicken, it swells with blood, becomes more fertile. It's trying to provide a place for that egg to implant into once it's been fertilized. If fertilization does not happen, let's say nobody comes to the party, right? We got all these decorations up, no one shows up to the party. Then we rip all the decorations down. The inner lining of the uterus begins to detach and shed itself. And the unfertilized cell and all the blood and all the tissue that was lining the womb all begins to shed outwards. And that is the menstrual discharge, the period. We can trace Using hormonal levels, we can trace people's, fertile days. So if you're trying to conceive, we can do a blood test and we can determine for that person, like their most fertile days, the best chance they have of conceiving, as well as the days where they have the least chance of conceiving. So if people are having reproductive issues there, we are able to kind of come up with a calendar for them. And ladies, I'm sure I have not told you a single thing that you didn't already know.
And I have a question.
Yes.
So when women are pregnant, the body naturally releases oxytocin.
During labor, yes.
Okay. And then when women have miscarriages, what's the hormone that does that? Or is there no hormone with that?
Okay, so the oxytocin is involved in childbirth. The reason I said that is because what oxytocin does is stimulates the smooth muscle to contract to help push the baby out. That's the role of oxytocin. After birth, the role of oxytocin helps with the release of milk. Let me clarify, not with the release of milk. It's released during breastfeeding to encourage emotional bonding between the mother and the child. Oxytocin doesn't have anything to do with lactation, right? The production of milk. It instead has to do with the emotional bonding that occurs between mother and child during the act of breastfeeding. So it's released during breastfeeding, not because of the milk, but because you look down and you see the baby suckling from your boob and you're supposed to love that baby. So we overload your brain with the love hormone to really make you love that fucking kid. The baby is getting the same dose, by the way, of oxytocin. Like as the baby is breastfeeding, its brain is doing the same thing, trying to chemically force it to bond with its mother. Oxytocin will be released during miscarriage if the baby is far enough along that the body has to engage in contractions to have the kid come out. But most miscarriages happen very early in the pregnancy, and usually the issue is a genetic issue with the baby or with a developmental issue, like an embryological thing. Either the genes didn't come together like they were supposed to, and it won't be viable. So a lot of times the body will just kibosh it. Many times you'll have a miscarriage, you'll never even know. I mean, it will appear as though or be timed as though it's a normal period, and you wouldn't even realize that you were pregnant or that you had miscarried. But oftentimes when it's gotten to the point that you know that you are pregnant and then you have a miscarriage, it's far enough along. It was usually an embryological thing, like the baby wasn't forming correctly, and the female body will sometimes terminate pregnancies if the baby isn't viable.
Okay, and then you said that's oxytocin that does that.
Oxytocin would be responsible for the uterine contractions, not for the miscarriage itself. Oxytocin comes into play when it's time to get the baby out, whether the baby is alive or not. If it's time to push to get the baby out, oxytocin contracts the muscles. But the oxytocin didn't have anything to do with the miscarriage. It's like why the body miscarried the baby. Oxytocin doesn't have anything to do with that.
Okay.
All right. Good stuff. Good question. All right. So the next glands we are going to look at are the testes. These are the male-specific glands. They are located in the scrotum, and they produce one hormone primarily, which is testosterone. Testosterone is responsible for the secondary male sexual characteristics. Testosterone is also, incidentally, responsible for primary sexual characteristics. So it is produced in the bodies of both men and women. Testosterone, for example, stimulates the growth of body hair. So ladies, when you hit puberty and you start getting hairy legs and hairy underarms and you have to start shaving your legs or your underarms, that's still testosterone. Like the only difference is men produce way more of it. Testosterone also stimulates aggressive tendencies, so that prototypical like male behavior, high amounts of aggression, competition, peacocking, things of that nature, as well as it triggers sperm production. It is also stimulated by the release of luteinizing hormone from the anterior pituitary. So the pituitary can produce the same hormone in men and women, and in women we stimulate the ovaries, and men we stimulate the testes. Kidneys. Generally, when we consider the kidneys, we normally think of them as a filter organ, right? Their main purpose is to filter out toxins from the blood and excrete waste products. Basically they gather all the garbage that's collected in the bloodstream and excrete it, leaving squeaky clean blood to rejoin circulation. But kidneys also have an endocrine function, not because of the adrenal glands, but the kidneys themselves produce several hormones that are very important in the body. One is erythropoietin. Erythropoietin maintains blood oxygen levels by increasing the production of red blood cells. So this is a hormone that regulates the amount of red blood cells that your bones make. Renin is another important hormone that increases blood pressure. And calcitriol, which is activated vitamin D. Calcitriol stimulates the absorption of calcium within your intestines, which will then, when the calcium is absorbed, where does it go? It goes in the bloodstream. So the blood calcium levels will rise. So activated vitamin D raises blood calcium levels. Good stuff? So here are the feedback loops, right? The basic pathways that these hormones will use. So the first we look at is erythropoietin, and we will begin at the top. So we encounter a condition of low blood oxygen. This could be for a variety of reasons, but for whatever reason, we are detecting there's low oxygen in the blood. This is detected in the liver as well as the kidneys. The liver and the kidneys will both begin to produce erythropoietin. This is released into the bloodstream, and as the blood goes everywhere, it will be carried to the red bone marrow. The presence of erythropoietin triggers an increase in the rate of the red blood cell production. So we start producing more red blood cells more rapidly. The higher presence of those red blood cells increases the carrying capacity of the blood. We can carry more oxygen with more cells. Now, the blood oxygen levels will either continue to be too low, in which case we release more erythropoietin and this cycle repeats itself again, or the levels return to normal, in which case we no longer have low blood oxygen, so we stop the production of erythropoietin, capping the level of red blood cell production back to normal, right? Good stuff? Cool. With the hormone renin, the main function is to increase your blood pressure. And so it's a bit more complex, but we start with number one. So your blood pressure falls. Again, blood pressure can fall for a lot of different reasons. Maybe you fainted, maybe you're falling asleep, whatever. Blood pressure falls, so the kidneys release renin. Now, renin has to be converted, so there's a lot of chemistry that has to happen. It's converted into an angiotensin, which has to be converted into angiotensin 1. We then use an angiotensin converting enzyme to convert angiotensin 1 into angiotensin 2. The presence of that triggers a raise in the blood pressure. Now, if the blood pressure gets too high, the adrenal glands will release aldosterone. Aldosterone triggers salt retention. Salt retention also increases your blood pressure. So here we either have to then stop producing renin to lower the blood pressure back to normal, or we continue increasing the blood pressure, in which case we need to reduce the amount of salt available, which is why people with high blood pressure have to be on a low sodium diet, because this is the part in the chain where having too much salt in your diet starts to send us into a positive feedback loop. So we either need to reduce the salt or we need to reduce the renin. But the point, we have increased blood pressure. That is what renin does. It increases your blood pressure. That is what I want you to know. Good stuff? Good stuff. All right, the last one is vitamin D. Now I'm gonna come clean with you guys. When I was preparing for class, I was looking over these charts, making sure that I understood them. And this is the one that just, I didn't really follow it. I didn't know where the arrows were pointing. I sat there and stared and I couldn't really make it out. But the main idea of this thing is pretty clear. If you just focus on this side of it, you just look over here, just ignore the man behind the curtain over there. When your blood calcium level falls below normal, we'll start right in the middle in the red circle. Blood calcium levels drop. The parathyroid releases parathormone, which increases the amount of calcium that is available. Osteoclasts will be stimulated to release those calcium ions that are stored in the bone matrix. So the osteoclast, the bone breakers, will dissolve the bone, send the material into the bloodstream, and now your blood calcium levels have risen. We will either then stabilize where we are, or it's still not enough, so we continue the cycle, or blood calcium levels are now too high, in which case another chain of events has to happen. Another hormone cascade needs to happen to trigger the osteoblasts, the builders, to pull mineral from the bloodstream and lay it down in bone tissue and reduce the blood calcium levels. What I want you guys to take away from this is that the kidneys produce calcitriol, which is vitamin D. It increases your blood calcium levels. The next gland we are going to look at, and I promise, guys, we are coming to the end of endocrine system. We are almost done with glands and hormones, I promise. Next gland we are going to look at is the thymus. Now, the thymus is located anterior to the heart and posterior to the sternum. So it is in between your heart and your breastbone. There are two lobes. The main hormone that is secreted by the thymus is a hormone called thymosin. Thymosins stimulate the development of T lymphocytes. Do you guys have done immune system already in another anatomy class? Yeah. Immune, yeah. So you guys remember the B cells and the T cells within the immune system? So what the B and the T tells you is it tells you where that immune cell went to school. Where did it grow up? Where did it go to school and learn how to be an immune cell? There are two main schools if you want to be a white blood cell. If you want to have an immune function, there's two main schools. You can go to school in the thymus. Graduates are called T cells. Or you can stay at your local community college and go to bone marrow college. Immune cells that mature in the bone marrow are called B cells. Immune cells that mature in the thymus are called T cells. Now, they do have different functions, right? B cells typically are messengers and they become memory cells and things of that nature, whereas T cells tend to be the ones that sound the alarm and the ones that do the actual fighting. They are your actual killer cells, right? The assassins of the immune system. B cells are more like grunt soldiers. They're the ones that you send out in heaps to die at the beginning of an infection, so you can really like wear your enemy down a little bit. B cells are also the ones that retain a memory of the antibodies that your immune system has made. So for example, chickenpox, right? You get chickenpox once and you stay immune to it forever. Some of those B cells transformed into memory cells. They retain the memory of how to make the chickenpox antibody. So anytime in the rest of your life you get exposed to chickenpox, those memory cells produce a bunch of that antibody and you never actually get infected. B cells and T cells went to different colleges, right? They have different alma maters, they have different functions, but they still work for the same industry. This chart here basically just gives you a medically translated version of the story that I just told you. So what we're doing here is tracing stem cells, undifferentiated immune cells, right? These are high school grads that don't know what they're doing with their life. High school graduated white blood cells. We have no clue what we're going to do. We are undifferentiated at this point. Some of them will be put into the bloodstream and migrated to the thymus. So they got accepted to, Thymus University. They become T cells, natural killer cells, helper T cells, all those fun things. Other cells remain at home, right? They didn't go out to the big city. They stayed at a community college. They got a really cheap associate's degree that lets them get into the same industry as their Ivy League colleagues. Immune cells that mature in the bone marrow will become a variety of B cells. Those, once they are mature, will then be migrated to the bloodstream, where they will be taken to lymphatic cells, and they will live out their lives doing their function, right, working at their grown-up job, in their real job once they graduate, in lymph nodes, patrolling the bloodstream, investigating sites of active infection, things of that nature. Oh yeah, the spleen, another common place of employment, the spleen. Good stuff, guys.
Yes. I have a question about why the ovaries are part of the endocrine system, not part of the reproductive system, because isn't that what we're like taught in elementary school, that the ovaries are part of the reproductive system?
Yes. So my answer to that is twofold. Number one, we remember that we really simplify a lot of things for kids, right? We give them a basis of understanding, and then as we get older and more sophisticated, we add to that basis. We were also told as kids that there were 3 phases of matter: solid, liquid, gas. There are way, way more phases of matter than just 3. There's like a dozen. So when you're told as a kid, right, ovaries are part of your reproductive system, that is true. Just like your pancreas is part of your digestive system, but it also has an endocrine function, because remember the definition of endocrine, right? It is a gland that produces a hormone. That's it. So any tissue in the body that is a gland and it produces a hormone, we call it endocrine. Just like the pancreas, right? We can debate whether it's one or the other or both. Realistically, it's both. It regulates and controls, literally dictating the cycle of your reproductive system. Therefore, it is a reproductive organ, absolutely. But it performs its function by using the hormone hotline. And if you're calling the hormone hotline, you're a gland, you're an endocrine system.
Yeah, that makes sense.
Yeah. We tell our kids there's 3 phases of matter. There's way more, right? Plasma is a whole phase of matter that does not behave the way that other types of phases of matter do. Non-Newtonian fluids. There are liquids that you can press your hand into, but if you hit it really hard, it becomes solid and you can't like penetrate it with force. You have to slowly push into it. The actual phase of matter change, like it becomes solid on impact, but it remains fluid when you use less force. Ferrofluids, there are liquids that respond to magnetic fields. I mean, there are just, let's not even start talking about things like antimatter and crap like that. I mean, there are way more phases of matter than just solid, liquid, gas, but you start kids out somewhere. And you do the same thing with anatomy, right? We learn, oh, your brain and heart and lung, and then we get more sophisticated, and it's way more complicated than what we teach kids. But understand, it is also way more complicated than what we're learning as massage therapists. We are getting a basic overview of a system. If we were going into being like physicians, I mean, endocrinology is fucking hard. If this was our profession, learning endocrine system, bro, I'm not cut out for it. I'll do skeletal analysis. How about that? I'll look at bones in the lab. That'll be my job. Okay.
All right, thank you. Yeah, so the ovaries are more of just the part that makes the hormones, and then the other stuff for the female reproductive system is just kind of like the
think about it this way.
Think about it this way. Not the carrier, but
you like plants?
Yes.
Yes. So think about it this way. You've got a greenhouse nursery where you grow little baby plants, and when they're ready, they are sent out of the greenhouse to go get planted, like in the ground.
Yeah.
So you, the caretaker, right? You would be the ovaries, the hormones. Using hormones, you nurture these little baby plants, and when they're ready, right? When one of these is ready, you select it to be taken out of the greenhouse and go planted in the ground. That would be the equivalent of the ovaries preparing one ovum per month to ripen and be selected for fertilization. When that ovum exits the ovary, it is now on a journey of its own. So you've planted that little baby plant in the ground. It is now up to Mother Nature. If the soil isn't right, if it doesn't get enough sun, right? If the ovum doesn't get fertilized, then it's no longer up to the ovary, right? The ovary did its job. We put out an egg that is fertilized and is ready to be fertilized. Just like we put a plant out of our greenhouse that is ready to be planted and live on its own. Whether it does or not is now its life, right? Whether the egg gets fertilized or not, the ovaries aren't responsible for that. They are just responsible for making sure that next month we've got a new, fresh baby ready on time to be shipped into the fallopian tube, and hope that one gets fertilized.
Okay. Yeah, so I guess you could just say the uterus and all of that is just basically the vessel of which it...
That is all the uterus is. The uterus itself doesn't function until there's a baby in it, right? Its lining will thicken and prepare for baby, but if there's no baby, we shed that lining.
Yeah.
The uterus itself is just a bag of smooth muscle. It's a muscly bag that squeezes itself. Without a baby inside of it, the uterus itself doesn't do much other than prepare for the baby, and then rip all the decorations off the walls in disgust when nobody shows up to the party.
All right.
Fun stuff, guys. Fun discussions. All right. I promise. I told you this already, but I'm serious this time. We are really close to the end of endocrine system. A few changes that occur within the endocrine system as we age. So as we keep saying with hormones, the main issue is either there's too little or too much. So as we age, there are some predictable changes. Some hormones will stay the same, some will become reduced over time, some will become increased over time. Hormones that remain the same will be things like insulin. It doesn't matter whether you're a teenager or 85 years old. You still have blood sugar. It's got to be regulated just the same. Insulin levels do not change as you age. Neither do stress hormones. So things like cortisol and adrenaline, these guys stay the same your whole life. You are just as able to respond to stress in old age as you are adulthood or adolescence. Now, hormones that will decrease over time, number one is growth hormone. The production of growth hormone drops off drastically at the end of adolescence. We tend to have this arbitrary number in our heads of 18, right? You think that's when you become an adult is 18. Legally, that may be the case, but biologically, you are not fully developed until 25. The final steps of development do not take place until the mid-20s. The last things that are getting patched up, right? The last few things to develop, the frontal cortex of your brain is finally finishing its full development. So you are not even fully mentally an adult until your mid-20s. Your personality centers, the things that adjust, or the things that regulate things like social behavior, attitudes, things like that, those things are not fully developed until 25. Your skeletal system isn't even fully finished. The final bone to fuse and become fully ossified in your skeleton at about 25 years old is your clavicle, your collarbone. We can even use that to tell the age of a skeleton. If your collarbone is not fully fused, we know that you're an adolescent. Bones complete their development on a precise schedule. I mean, within a couple of years, you can narrow down the age of a skeleton just looking at different stages of its development. Aldosterone and sex hormones also decrease over time, right? Our libidos tend to decline as we age. But other hormones will increase. So luteinizing hormone and follicle stimulating hormone, these guys will continue to increase as we age. Now, females will go through certain menopausal changes. And again, those are all hormone based. But the chief thing that notarizes menopause is the cessation of production of estrogen. And since your estrogen levels decline, they're not producing estrogen anymore, your ovaries will begin to atrophy away. Again, if the gland isn't needed anymore, we're not going to spend the resources to maintain these cells, right? Those cells are consuming energy, they need blood supply, which means we need living cells of the blood vessels, right, running to them, right? Capillaries are made out of cells themselves, right? Blood vessels and everything. So all of the other infrastructure that goes along with them, the layers of smooth muscle that are used to make the glands secrete, all that infrastructure, if the glands are no longer functioning, then the body will start breaking that material down and recycling it. So your ovaries will atrophy, estrogen levels will continue to decline. There you go. Changes with age. And lastly, we have our massage effects on the endocrine system. Now, since the endocrine system is the basic mechanism as to how the body is switching between sympathetic and parasympathetic, right? Fight or flight, rest and digest, switching us from our stress response to our normal relaxed response. The effects of massage on the endocrine system chiefly are about restoring relaxation, right? Activating the parasympathetic things. But we also have an autonomic or a sympathetic function. When Swedish massage begins, the first 10 minutes or so, you are actually stimulating their sympathetic system. You are increasing the levels of stress hormones. It's not until about 10 or 15 minutes into the session that those levels begin to lower and we actually begin to activate the parasympathetic system. Consider it. Think about how many massages you students have had at this point. The first few minutes of the massage, you're actually much more active. It takes a while for your brain to be able to really relax. Even if you are able to fall asleep on the table, you don't fall asleep as soon as you hit the table. It takes a while for your brain to really settle itself down. Massage initially spikes adrenaline and cortisol levels. After about 10 or 15 minutes, those levels lower. As the cortisol decreases, that is how we can say we do things like reduce stress, right? We equate the reduction of stress by a reduction of cortisol. We also balance mood and reduce food cravings by increasing the production of serotonin. And these feel-good chemicals that we release when we get massage called endorphins, they also blunt our perception of pain. So massage can release or relieve the experience of pain. Good stuff. Cool. All right, contraindications for massage. We talked about diabetes already. Patients with who are diabetic may be lethargic due to their blood sugar imbalance. People with low blood sugar, they tend to be, they get a little loopy, they get a little lightheaded, like they're a little fainty, kind of. You can offer them a piece of hard candy. Hard candy is recommended because they suck on it for a while, so it slowly increases their blood sugar rather than just giving them a straight up piece of candy, which will spike their blood sugar very quickly. Hard candy, just something a little minorly sweet like butterscotch, something like that, just that gives a little trickle of sugar over a prolonged period of time. But we also want to be aware that if they start getting too lightheaded, right, or they start fainting on us, then we stop the massage. You can't massage someone who's fainting out on you. Hypertension may also be a thing. Type 2 diabetes is often comorbid with heart disease, high blood pressure, things of that nature. So if they do have high blood pressure, or if their diabetes is accompanied by neuropathy, which is also very common, especially in the feet, their nerves are not sensitive to pressure or temperature changes. So if you put hot stones on them and they're too hot, they won't feel it. So you'll just sit there and burn them and they won't complain because they don't feel the burn. They won't notice it until they actually see the burning on their skin, usually a while later. This is why diabetics have to check their feet regularly. If they have neuropathy, you want to be very, very careful. No heat on diabetes. Be very, very cautious with firm pressure. Again, just because if you're going too deep on them, they may not feel it. So they won't be able to tell you that you're going too deep. Another contraindication for endocrine disorders is clients who are taking corticosteroids. Corticosteroids are anti-inflammatories, but this can also lead to tissue weakness, so they bruise very easily. So you can't use firm pressure if they're taking steroids. They will bruise very easily. I mean, I've seen photos in magazines and things like that where the therapist would take like an elbow and you glide the elbow along the spine and they end up with this strip of bruise along the spine because it was just too much for them. Also, corticosteroids inhibit your immune system, so they tend to be more prone to infections. So just remember to really wash your hands. If you feel like you're sick, make sure you wear a mask and protect the health of the client because their immune system can be suppressed. There's also an increased risk of deep vein thrombosis, which is a condition where they develop blood clots in the larger, deeper veins. It more often affects the legs. But the risk here is that, especially if you're using really deep techniques on the leg, if you dislodge that blood clot and send it floating through the bloodstream, it can get stuck in the more delicate vessels, like in the lungs or the brain or the liver, and that would be really, really, really bad. If a section of this organ suddenly had its blood flow stopped, right, you dam up the blood supply with a blood clot, all the tissue downstream of that clot will begin to die. And remember, oxygen is priority number one. Cells can only last minutes without oxygen. So if you work too deeply on a client with deep vein thrombosis and you release a blood clot, it can become life-threatening very, very quickly. Oftentimes more quickly than we can get them to an emergency room if it's happening somewhere like in the brain or in the lungs. So we avoid deep tissue work on clients with diabetes or clients who are on corticosteroids, mainly out of an abundance of precaution. Again, I don't want to give you guys the impression that, you know, if you push too hard on anyone with diabetes, you're going to throw blood clots in them. The risk of is not likely that these kinds of things will happen, but we always err on the side of caution, right? Remember the first rule of massage. What is the first rule of massage, guys?
Do no harm.
Thank you. I was like, oh God, please. Rule number one of massage, do no harm. Always err on the side of caution. That has been the endocrine system, guys. Was it fun? Was it fulfilling? Did it change your life? Are you now in love with this organ system now? Yeah.
It's always been my favorite. I love it.
Yeah. Well, man, you're a rare breed.
I second that.
Most people run.
I love this chapter.
Yeah, most people run screaming from the endocrine system, but I'm glad you guys enjoyed it. I am glad you guys enjoyed it. I'm about ready to take a break. When we come back from break, we will begin male reproductive system. We will see if there's any questions, and that will be it for the day. Good stuff?
Good stuff.
All right. It is 2:41, so we'll put 15 minutes on the clock, and I will see you guys back here very shortly.
when I pointed out that
All right, everybody, we are back. So for the second portion of class, we are going to talk about the male reproductive system. There are 12 slides on this presentation, so we should not take very long. We'll start out with talking about the process of sexual differentiation. So as you guys may be aware, when the sperm and the egg come together, each of them only holds half of the genetic information needed. They only have half the material. It's only once the two come together that we now have a complete genome and can then create another human. When females produce their eggs, the eggs are always copied with an X chromosome. So the females will always contribute an X. Sperm can either contribute an X or a Y. If they contribute an X, we've got 2, the baby will be female. If there is a Y, this will trigger the production of testosterone early in fetal development, which will then cause the child to become male. So on one hand, we can say that being female is the default, meaning testosterone has to be released to trigger the infant to become male. If you don't, then it'll just be a female. So when Harry VIII executed, all of his freaking wives because they kept having daughters, he should have executed himself because it's the sperm that determines the sex of the child.
So is that like a genetic kind of trait thing to like have more girls over boys or whatever? Because I've got friends who have like 4 kids and they're all girls, but then I also have friends who have like 3 kids and they're all boys. So is that kind of like a normal thing?
On one hand, it is luck of the draw. I mean, it's every time you have a kid, you got a 50-50 shot. However, some individuals will, particularly men, will have genes that tend to make more of their sperm produce either X's or Y's. So what you're looking at there is over all of the sperm that this guy will make over his entire lifetime, he will produce slightly more of one sex than the other. Like those kinds of trends you could see. But
okay,
remember,
that makes sense.
There are 10 million some odd sperm produced like every day. I mean, it's just an ungodly amount of sperm being produced all the time. From the moment of puberty, a boy's testicles begin to produce sperm. They never stop. They will produce sperm until the day they die. As we age, those sperm will become more decrepit and like less motile and things like that. But I mean, if a man is celebrating his 109th birthday, you can still take an active semen sample from him and there will be live sperm in it. Women, on the other hand, since they only contribute X's, but that's all women. So women cannot express genes to prefer boys or girls. Sometimes women's bodies will trigger an immune response to a male fetus. But that's usually not terribly common.
Okay, that sounds good. I just didn't know if there was like a correlation between all of that with people having more of one than the other.
Yeah, you can talk about the probability of producing one over the other in men's sperm over his lifetime, but usually what happens is it's just a luck of the draw. You got a 50-50 chance and you flipped a coin 3 times and you got heads all 3 times. Congratulations. Unfortunately, you didn't get to collect the set. You know, it's always nice to have. All right. In utero, the XY chromosome signal, the Y chromosome signals the release of testosterone. The presence of testosterone begins the embryonic formation of male genitalia. Therefore, if testosterone is not released, then the genitalia will develop, quote unquote, normally, becoming female genitalia. This is what we mean when we say it's the default. The male stuff has to be triggered. If it ain't triggered, the embryo will develop as a female.
And
Since
is the testosterone signaled in the embryo, or is it signaled in the uterus when the baby's growing?
in utero, from the baby, from the fetus.
Okay.
Yeah, as it begins to develop, early in the stages, the X chromosome begins to express itself. It expresses itself through the production of testosterone, and the presence of testosterone triggers all the other changes that lead to a male fetus. So I will say this, embryology and the study of all of the minute-to-minute changes that go on in development, first of all, I'll say is wholly outside of our scope as massage therapists. I mean, none of that is imperative to what we do as massage therapists. So let's just understand that there will be none of that kind of information on the test, first of all. Second of all, as its own branch of science, embryology is exceedingly complicated. We tend to think about tissues in very mechanical terms. When you get into embryology, you really have to take more of an origami mindset. What you're dealing with is stages of tissues that are in 3-dimensional space. They are kind of caving in on themselves, or they are swelling and beginning to protrude out in certain areas. And it's this repetitive over and over, like folding in and then more folding in. It's a process called invagination. It's where the root word of vagina comes from, a folding in. But this is how the body just develops. I mean, your spinal cord develops as a balloon that spreads out into 3 distinct sections, and then it like making a balloon animal, right? This tube just starts to like twist and bend itself, and don't ask me how, but at some point it becomes a brain. I can't explain it any more than that. What I can talk about, since we're on the subject of embryology, and before the slide jumps into the next topic, since we're talking about genital development in utero, I would like to explain one thing, which the second we start talking about male anatomy, right, male sexual anatomy, I can feel the question on everyone's minds right now. And I want you to know that I sense the question on your mind, and I am going to address it, so you can all take a deep breath. It stresses everybody out when we start asking, why does the scrotum have a seam? Like you were stitched together from 2 separate people's ball sacks. Like what? Why is there a seam?
Definitely was not even thinking that.
You're lying. You're lying to me. So the answer comes in when we remember that female is the default state. So if you start out by kind of thinking about female anatomy, like where like the ovaries are hanging up here and stuff. So if we begin this process, right, we begin the process of forming a female reproductive system. But then along the line comes this huge influx of testosterone. And this changes the processes that embryology is taking. So what happens is the clitoris becomes enlarged and expands out, becoming the penis. The ovaries descend down into the labia majora and swell. The labia majora become the scrotal skin. And as the outer labia close around their old ovaries, their new testes, As the vaginal lips close, they seal themselves shut, and that is the seam in the scrotum. It is where your proto-vagina closed up on itself, leaving your old ovaries dangling down, which are now testes. The clitoris expanded to become the penis, and there was another something or other in there. I think the uterus maybe withers away and becomes a prostate, which just, it's a glorified juicer. That's all. It just squirts juice. The prostate provides most of the liquid that is expelled during ejaculation. The sperm cells are microscopic. They have to be floating in a liquid, and most of that seminal fluid is produced by the prostate. So that is why scrotums have seams. There you go. I know it was a burning question in your minds. I can feel it. So now that we've got
to know that, before I want to just say something real quick, Dave.
Yeah.
I love that, by the way. That was great. But that also segues pretty well into. I just want to offer. I won't take up a lot of time with this, but there are more combinations to than just XX and XY. And many people actually are born as what's called intersex. And I really encourage you, especially as you're working with bodies, to look up what that means and how that can affect people's bodies and people. And that it's a little bit more complicated than just that binary, but it's a super deep rabbit hole to go down. And if you're curious, I'd love to chat with you after class.
Thank you for that, Luke. And I would like to say, as I said earlier, all of these organ systems are far more complicated than we can give credit to them for in the time that we have. So yes, while we boil down to basics, XX, XY, the reality of the situation is, just like there are way more than 3 states of matter, there are more combinations of this. It's just that they are less common, but that does not mean that they are not understood and documented. I myself taught a student with a chromosomal disorder in Florida. He had XYY syndrome. So he had a second Y chromosome, and he was the sweetest guy. Like, when I say a huge teddy bear, like, he was the sweetest guy. But he had the most jarring, deep, booming voice with almost no emotion behind it. He had this loud, booming, monotone voice. And he would get excited about stuff, and his laugh was very dry and like, heh, heh, heh. Fun guy. But yeah, there is way more to this, guys, than I have the time to go on in a handful of slides. Especially when we start getting an embryological development. That's a whole freaking branch of science all by itself. I wish I had the time. I wish I had the qualifications, to be honest with you. Thank you, Luke. Thank you for that. All right. So we started out with male reproductive system. We're looking at an XY chromosome setup. The Y chromosome triggers the release of testosterone, which then triggers the development of male genitalia. Puberty is onset generally in females slightly earlier. Puberty usually onsets in females between ages 8 and 13. Males, it's typically 9 to 14. This not only triggers the development of what we call primary sexual characteristics, which is to say the maturation of the gonads. We start producing sex cells. The person is now sexually mature. But we also start manifesting secondary sexual characteristics, such as breasts, body hair. For men, it's the deepening of the voice and the broadening of the shoulders. For ladies, the development of breasts and the modifying of the body curves. So as your hips begin to widen and your bosom begins to develop, you start to develop that more hourglass figure. With men, also, we see an increase in muscle mass, particularly in the upper body. The external genitals not only develop hair, but they also become larger. And the hormone that is triggered, that is released, that triggers all of these, is a hormone called GnRH. I know that's a really catchy name. But GnRH is the hypothalamic hormone, the hormone from the hypothalamus. When the hypothalamus produces GnRH, it's picked up by the anterior pituitary, and then the anterior pituitary, as we've seen, releases follicle stimulating hormone and luteinizing hormone. And those hormones are the ones that we've talked about. They go on and have their reproductive functions in the system.
Is it true that females also have some testosterone?
Yes, they do. Yes, it's the same testosterone that's responsible for the growth of body hair in females. The only difference is the amount. Men produce far, far more testosterone than females do, but females absolutely produce all their own testosterone, and that's what triggers the body hair growth. Yeah. Women produce smaller amounts of testosterone than men, but it is my understanding that men do not produce estrogen. I may be mistaken on that, but that's my understanding, is that it worked one way, but not the other. Women would produce testosterone, but men typically did not produce estrogen. Oops. So the male reproductive system is comprised of a penis. Forewarning, guys, I'm gonna have to say the word penis a lot, and like scrotum and testicles. So go ahead and get your giggles out now. Get all your giggles out, and then we got to get back to it. So the penis is the main male reproductive organ. It is divided into sections, which are the root, body, neck, and head. The foreskin of the penis, or the prepuce, is what is removed during circumcision. So if you've only ever seen a penis that looks like that chart, then you've most likely been looking at circumcised penises. They are less common. I'm sorry, uncircumcised penises are less common in the United States. However, in the rest of the world, circumcision is nowhere near as popular as it is in the United States. The urethra is in the center of the structure. It's surrounded by a highly vascular, meaning there's a lot of blood vessels, spongy tissue. These blood vessels are extremely elastic, which means they can expand and hold a crap ton of blood. And this is how the penis gets hard. When these tissues are engorged with blood, causing an erection, there is so much blood present in the penis that the penis becomes extremely stiff and rigid. Below the penis is the scrotum. This is a sac of skin which hangs outside the abdominopelvic cavity. The reason that scrotums the testicles are held outside the body, as opposed to females who hold their gonads within the body, is their function, sperm production. Sperm require a slightly lower temperature than body temperature in order for them to mature properly. So what we want to do is hold these maturing sperm slightly away from the body so that they don't get quite so much heat. Now, if it gets too cold outside, right, then what we want to do is retract the testicles into the body to get them closer to the core so that we can keep their temperature constant. This is why you'll notice, if you've ever heard the famous Seinfeld joke, right? There was shrinkage. I was in the pool. Oh, you had shrinkage. You had shrinkage. When cold temperatures come along, the skin and the smooth muscle within the scrotum will contract, bringing the testicles closer within the body. The whole point of letting them hang or tightening them up, the whole point is to make sure that they stay at an optimal temperature. Sperm are rather delicate. You don't want to burn those suckers, but you don't want to run a yolk either. It's got to be over medium. Now, I swear to you guys, I am not making this up. If I'm lying, I'm dying. There is a muscle that is responsible for contracting the scrotum. It is also the same muscle that is responsible for contracting and actually ejecting the sperm during ejaculation. That muscle is called the cremaster muscle. Cremaster muscle. I did not make that up. That is a real thing. You can look it up. I'm telling you. Yes, the cremaster muscle pulls the scrotum either closer to or relaxes and drops the scrotum further away from the body. It is also the muscle that contracts to actually eject the sperm to then mix it with the prostate secretions. It's the master of the cream, what can we say? So these allow the testes to regulate their temperature so that the sperm is always maintained at its optimal temperature for development. The two testes are the gonads. They are located within the scrotum. Typically, they are oriented one on the right, one on the left. It is common for one of them to hang slightly lower than the other. That is not abnormal. That's a normal thing. They can also slightly vary in volume. So it is also normal for one to be slightly larger or smaller than the other one. What is not normal is for one of them to suddenly begin changing in size, either larger or smaller. That is not normal. It is also not normal for them to be exceptionally tender. You should be able to get a good grip on them and kind of squeeze them a little bit with mild tenderness. But if they are ever overly painful, it should never hurt to touch. If they do, you need to get that checked out. A common condition that happens is called a testicular torsion, which is where the testicle rotates in place, but the cord that it's stuck to also twists, and now it's pinched off. And that can obstruct blood flow, and it can kill sperm, and you can lose a testicle, and it's really painful, and it's really, really bad. Also, any abnormal growth, any abnormal change in size of the testicle, I mean, I know we want all, bigger the better, but if they suddenly become very large overnight, this is extremely concerning. There are a lot of things that could be going wrong with them, not the least of which would be testicular cancer. So the reason they're getting larger is because there is a tumor in there. Another one of concern is a scrotal hernia. And this is a really, really fun one where a piece of your intestine slips out of the hole where the tube goes in. Remember we said your testicles are dangling by a tube. Well, the tube has to exit your abdominal cavity. So there's a hole for it. And through that hole, if some of your intestines fall out, then the intestines can fill the scrotal space. So your scrotum can swell to the size of a basketball because it's all full of guts. True story. If the fact of that knowledge is not traumatizing enough for you, do a Google search on your own time of scrotal hernia and be terrified. It will give you nightmares. If you have a scrotum, it'll give you nightmares. So the primary purpose, as we said, of the testes is their endocrine function. They produce testosterone. They also have a reproductive function. They produce sperm. Sperm is the male reproductive cell. The head of the sperm contains a nucleus comprised of 23 chromosomes, which is only half of the material that we need in order to make a baby. The tail provides motility, which is the technical word, which just means it can swim around. It has a flagellum that kind of spins around like a propeller and moves the cell within a fluid matrix so the guy can swim around and sniff out the egg. Sperm production is stimulated by follicle stimulating hormone. So remember, guys, you're looking at what we call analogous structures. The female system, you're looking at an ovary that produces one ripe egg every month. You're looking at the same kind of structure in that you're looking at basically an ovary that is producing tens of millions of ripe eggs every day, right? The difference is one egg is going to be really large. The 10 million sperm, they're all going to be really, really small. At the end of the day, that is the defining characteristic between male and female sex cells. It doesn't matter what animal or plant you're looking at, the female, quote unquote female, will always have the larger sex cell. The quote unquote male always has the smaller sex cells. That's a constant thing in biology. Sperm production is stimulated by follicle stimulating hormone and testosterone. We can produce about 20 to 100 million sperm per milliliter of semen. That is there's about 2 to 5 milliliters per ejaculation. Considering all the genetic information that these sperm contain, another fun fact, common normal sized ejaculation can hold up, I think it was 32 terabytes of information. 32 terabytes. That's really fast data transfer speeds, guys. 32 terabytes in like 5 seconds. That's a lot. All right, so sperm proper is the cell itself, right? The reproductive cell, it's a haploid cell, so it only has half the genetic material that it needs. However, when a male ejaculates, the total body of fluid that is ejaculated is called semen. The semen is the mixture of sperm and fluid, which is produced from accessory glands. The fluid can be produced in your prostate glands as well as bulbourethral glands. There's lots of other glands in there that are producing stuff. The chief among them, the main one to stick in your brain, is the prostate. That's its primary function. We are all adults here. You can ejaculate without sperm. It would be a clear, kind of sticky mucus-like fluid. That is the semen. It often goes by the street name precum. That is the fluid that is excreted by the prostate. It's only when it's infused with semen from the testicles that it becomes, you know, live semen. So within the system, we have lots and lots of tubes. The testicles themselves are just this incredibly complicated loop of tubes that actually have, one of the names of these sections is actually quite apt. It's called the convoluted tubules. And it's just a system of tubes that just go all the way. It's a very convoluted, very complex looking thing. So these tubes or ducts come in a lot of different types. One tube that we have is called the epididymis. This is a coiled tube that receives sperm from the seminiferous tubules. So the epididymis is this wrinkly guy here. There's its tail. As we head up, you have the vas deferens. So the vas deferens is the big one. This is the one that you normally think about. The vas deferens is the tube that your little testicles are hanging out from, right? This is also the tube that they aim for when they do a vasectomy. When they do snipping, they cut and cauterize the vas deferens. So you continue to produce sperm, but the roadway to get to the outside of the body, the road's gone. So you'll continue to produce viable sperm, but then they will age in your testicles and then they will get too old and your body will kill them and recycle them. So you'll consistently continue producing viable sperm. They have no way out. With the two ends of the vas deferens being cauterized off, they can also have snip off the cauterized ends and rejoin them together. So vasectomies are reversible. If you later decide you want to have kids after a snip job, you can go back and have it reversed. So the head of the epididymis is this little guy here, and it is collecting all of the viable sperm in preparation for ejaculation that have been produced by the testicle. So within the testicle, you have the seminiferous tubules. Pay attention to that root semen in this word. This is where the semen or the sperm is actually being produced. This is where the sperm cells are growing up and going to school. I do not want you guys to focus so much on all the delicate words in here, like lobule and, oh, there's a septum in there. Just seminiferous tubules, epididymis. Vas deferens, okay, so yeah, this is the next one that I talked about. Vas deferens is located in the scrotum and in the abdomen. It is suspending you like a chandelier from the abdominal wall. The vas deferens has a bunch of nerves and blood vessels along with it through the spermatic cord, and it receives sperm from the epididymis and carries it up into the abdomen. Inguinal hernias occur where the spermatic cord crosses the abdominal wall. And again, vasectomy is a procedure that ties off the vas deferens for male contraception. So I will show this to you guys real quick. So again, we're dealing with reproductive system. I ask us to be adults. So there is our urogenital system. And what I'm looking for is here. There's what I'm looking for. Awesome. So this is what I was looking for. Notice that there is a hole in the abdominal wall for the spermatic fascia and all the stuff that's within it to hang down from the abdominal wall. So if I hide this guy, right? Ooh, and yeah, there's muscle in there, guys. If I hide all that stuff, we can see there is just a nice little discrete hole in that abdominal fascia. Now, if an organ becomes protruded through that hole, usually it's going to be a piece of your intestine. That would be an inguinal hernia, a hernia in the groin. These are the more common ones. They are very painful. They often will require surgery. They have to open you up and kind of stuff your organs back in you and stitch up the hole a little bit. But if the organ begins to protrude all the way down into the scrotum, then you have a scrotal hernia. And again, trigger warning if you want to do a Google search on that. It is nightmare inducing. Just gonna say.
And how does something like that occur?
Usually it occurs through a combination of a weak abdominal wall and a lot of force. So usually what happens is a person with a weak core tries to lift something really heavy, and they lift improperly and put a lot of weight in their pelvic floor muscles. And you put so much pressure on the organs, and the hole underneath is really weak, and suddenly you pushed organs through the hole.
Okay.
Yep. Weak muscles and overexertion is usually the chief cause of hernias. Now, you can also get hernias up at the top. Remember, your diaphragm has holes in it, right? For the aorta and your esophagus and all that stuff. So you can have hernias up at the top as well, but we're dealing with reproductive system. So these are the hernias that you find in this department. They're usually inguinal or scrotal. All right, so inguinal hernias occur where the spermatic cord crosses the abdominal wall. That's what we just saw. There's literally a hole where the spermatic cord exits the abdomen and goes outside of the body to suspend the testicles outside the body. The vasectomy is the procedure that ties off the vas deferens. In the word vas deferens, the word vas means vessel or tube. So a vasectomy is the name translates to a tube removal, which technically speaking, you're removing a piece of the tube, but it's more of like a cut and cauterize type deal. I think all the fellas in this class are a little too young, but I've spoken to several older guys who have had vasectomies done, and you're awake during the procedure, and they even say like you'll smell a little bit of burnt skin when they sear it off. Yeah. And then you have to ice for a couple of days, and you can't lift anything really heavy for a couple of days, and you got to wear sweatpants for a couple of days because you don't want to restrict the boys. But you basically just get a few days of lazy video gaming and ice cream eating. That's what I've been told. All right. So other important structures, we have the urinary bladder. The urinary bladder in males sits directly on top of the prostate, and there is a tube running through them. So when the prostate becomes inflamed, as it typically does in older age, since the tube is running through the prostate, when the prostate becomes inflamed, it squeezes down on that tube, which you feel like you have to pee, but then you stand up to go pee and nothing comes out. You just get like a few little dribbles of pee, but it feels like you have to pee. This is another common complaint with men as they enter middle age and older age, is that they have a trouble going to the bathroom, and it's usually because of an inflamed prostate, because again, the tube runs directly through the middle of the prostate. So when the prostate swells up, it pinches off that hose. Seminal vesicles, located posterior to the bladder. Seminal vesicles are also producing semen, the fluid component of the ejaculate. They contribute about 60% of the seminal fluid, as well as nutrients for the sperm, pack them a lunch on their way out. The prostate sits beneath the bladder, surrounds the urethra. It contributes about 25% of the seminal fluid. It is also contributes chemicals which are acidic as well as antibiotic, and it activates the sperm. So letting them know, like, show's on, boys, put your sniffers on. The bulbourethral gland is inferior to the prostate. It produces a thick alkaline mucus, which cleanses and lubricates. Oh, hold on, sorry guys, I'm getting caught up on the chats. Here, just eating. Oh, sorry. Brother has XXY called Klinefelters. Interesting. Yeah, the student that I had XYY. So we had 2 Ys instead of 2 X's. Haley, for the notes, I would stick to the slides. When I go on a random rant, I assure you it is not on any test. That's just me being a nerd.
No, it was a joke. I'm following along.
Good. Pre-cum can actually contain sperm and impregnate a person. Yes, pre-cum can absolutely contain sperm and impregnate a person and transmit STDs. Absolutely. What are you saying? An easier way to prevent unwanted pregnancy? You're talking about vasectomy?
Yeah, vasectomy.
Yeah, they should be free, like provided by the government. Like every guy should have a vasectomy by the default. And then you have to like opt out of it if you want to have kids. That's my opinion. That's my opinion. I just think we have way too many freaking kids on this planet. That's me being a curmudgeon, sorry. Such an easier way to prevent unwanted pregnancy. Yes, it does not have anything to do with prevention of STIs though. It only prevents pregnancy. Yeah, and vasectomies are generally low risk, but oftentimes the burden of birth control falls on the female. And you guys have probably been wondering, like, how come there's a million different birth control pills for women, but no birth control pills for men, right? But again, think about the mechanics of what's happening. With a male, if you were to give him some kind of pill, right, the pill has to stop millions of cells from developing every day. And if even one of those cells survives, the efficacy of the drug is nil. With a female, the drug only has to prevent 1 egg from maturing per month. That's it. So just from a target standpoint, it's a lot easier to develop birth control for females because you've got 1 cell to stop a month versus trying to develop birth control for men, which we can do. The irony of ironies is, and ladies, you're going to get a kick out of this, is when they've tested male hormonal birth control pills, the men can't handle the side effects. They just get so emotional and crampy and they just can't take it. And I'm sure every
reading a thing
single,
about that.
Yeah, and I'm sure every single female is like, get over yourself. We deal with this every fucking month. Like, seriously. But no, bro, men are fucking babies. And it made them a little weepy and a little crampy, and they just couldn't do it. The side effects were too strong. Yes, that is exactly what happened. Yep.
So
there is
sorry.
Go ahead. No, go ahead.
I was gonna say, so I'm 27 weeks pregnant now. And
congratulations.
Thank you. So my partner though, he is on a wait list for a vasectomy, and so I was on the pill. However, I have PCOS and irregular periods. So all the birth control pill did was regulate my period, and then I got pregnant while on the pill. So it literally helped me get pregnant. So
yeah, and that's very common. A lot of people are prescribed birth control not because they don't want to get pregnant, but because they have PCOS or they have endometriosis or some other condition in which the birth control just regulates the hormones, which naturally are going crazy. So by artificially putting them on a hormone schedule, it allows the body to regulate some of those normal processes. Yeah. Congratulations. It certainly is not unheard of.
Yeah.
There are many people put on birth control for reasons other than actual birth control.
So how would they avoid getting pregnant then if, like Shea, after she has this baby, if she doesn't, have her tubes tied or whatever, how does she avoid getting pregnant if the birth control pill doesn't work?
She makes her boyfriend get a vasectomy.
Yeah, he is for sure. Yeah.
Yeah,
it's not. Birth control.
My argument is it's not just on her. My argument is not just on her. Like, he is equally involved in this. So.
But maybe they both.
And again, look at the side effects of those birth control pills, man. I mean, the weight gain and the mood swings and the bloating and the irritability and if it's not for you, I get it. It's not for you. There are plenty of other ways to make sure you don't have a baby. I'm sorry if he might be a little uncomfortable for a week, but it's reversible.
And
And
it's
then just the mental burden of
being
having to remember to take
uncomfortable.
that goddamn pill every day, bro. You got to take birth control pills every single day. That's a mental burden every day at the same time.
At the exact same time, or they are ineffective. And you can't
Make
drink
him do that.
orange juice
Make
or
him do
pineapple
that.
juice.
You think he would take a pill every day on time at the exact same time every day, faithfully? You think he would do that?
You're
My
awesome.
experience with men suggests otherwise.
You're awesome.
Make him get his nuts snipped. If you decide to have another kid, he can have it reversed. No big deal.
No, he's done. We're done. We're good.
Shaya, this is what, your second?
Yes. Yep. One girl. I'm good.
One girl, one boy?
Yep.
Oh, you got the set. Perfect.
So I got the set, yes.
You got the collector's edition. Nice. The only way to be better is a boy-girl twins, man. One good pop and you got them both and you're done. Okay, a kid. All right, where were we? I lost my train of thought. Bulbourethral glands. It's inferior to the prostate. It produces thick alkaline mucus, cleanses and lubricates. The reason for the alkalinity in the mucus is because the vaginal interior is more acidic. So secreting an alkaline product with the sperm neutralizes some of the acid and ensures that the sperm can live long enough to penetrate deeply enough to fertilize the egg. Fertilization usually happens in the fallopian tube, which means those sperm have to a long way to go before they reach the end of the race. Not only do they have to make it across the cervix and through the uterus into a fallopian tube so that they could then encounter the egg and be the one to fertilize it. But they got to spend a lot of time out in no man's land in the vagina, and it's very acidic out there. So give them a little bit of acid wash or alkaline wash on the way out, helps them last a little bit longer. A vagina is not a very hospitable place to sperms. I just gotta say, you don't make it easy for them, guys, ladies. All right, so here is, I believe we're looking at a posterior view. So you're looking at the back of the urinary bladder, and then inferior to that, you have the prostate gland. You can see the prostate gland is literally wrapped around the urethra. The seminal vesicles are back there as well, and they are connected to seminal vesicle ducts, which is seminal vesicles and seminal vesicle tubes. The ejaculatory duct mixes the secretions of the two together with or within the urethra, and men use the same tube. They pee and ejaculate out the same tube. I know, guys are gross. At least females have separate tubes for that kind of stuff. Here's a sagittal view. So we've cut the body right down the middle and just opened it up so you can see the inside of it. The large cavern at the top, you can see there's the bladder. The prostate is there, kind of in the middle between your seminal vesicles on the posterior side and the urethra, which will then continue traveling down to the tip of the penis. One thing I would like you guys to note is the vas deferens on the back side of the scrotum, on the posterior side of the scrotum. Just note that that vas deferens runs over the anterior portion of the pubic bone, runs posterior across the bladder, and then finally inserts kind of on the posterior side of the bladder. So it goes completely up and over. I just wanted to call that to your attention, just to see where that cord is laid out. Lastly, the human or the male reproductive system is regulated by the nervous and the endocrine systems. Within the nervous system, we have the hypothalamus. We talked about this already. We make GnRH. Where do we see that up here? Right here. We make GnRH in the hypothalamus, which triggers the anterior pituitary to produce luteinizing hormone and follicle stimulating hormone. Parasympathetic and limbic system play a role in sexual arousal. So again, we're looking at a balance between sympathetic and parasympathetic for this. If you are super stressed out, you typically do not have a sex drive. That is because your body is aiming you to run away from a bear, not get laid. We have more important priorities on our plate. So the nervous system and the hormonal system, if we are in sympathetic mode, typically we have less of a sex drive. We require parasympathetic stimulation in order to be able to experience sexual arousal. So you got to be in an area where you are, relaxed. But the sympathetic system is again responsible for orgasm. So the increase in heart rate and respiration, right, as the body tends to, like you've been exercising, right, or stressed out, right, as those functions become more stimulated, that is a stimulation of the sympathetic nervous system, responsible for orgasm. The anterior pituitary, as we said, releases follicle stimulating and luteinizing hormones. The luteinizing hormone target the testes, which cause testosterone production, and the testosterone stimulates sperm production.
What kind of symptoms do men have when they have low testosterone?
Typically, one of the more noticeable ones is just a lethargy, like they just get lethargic. They also have a very reduced sex drive. They may struggle to gain muscle mass if they're working out at the gym. Testosterone levels are expected to gradually decline as you age, but many guys will go on supplemental testosterone replacement just to keep their levels at higher levels. One of the more, so like, he's not going to go to his doctor because he can't lift extra weight, right? He's not going to go to his doctor because he's too tired to get off the couch. What's going to get him to his doctor is he can't get it up. And either he or his wife is going to make that gentleman an appointment to go see his doctor. And the doctor will run some blood tests and determine he has low testosterone. But that's usually the thing that gets them in, is that they got to go in because they can't get it up. Or they have just no sex drive. Like they're never in the mood. If they try, they could get it up, but they just don't ever want to try. They just don't have desire. Good stuff. Good questions. All right. Any other questions, guys? We've covered quite a bit today. So let's scroll back up to the top and just do like a quick bullet point review from the notes that we've taken. So we started off today talking about melatonin produced by the pineal gland, which is in almost the geographical center of the brain. Melatonin is responsible for regulating your circadian rhythms, your day-night cycles, as well as sexual development and the onset of puberty, and it has an immune function. The next gland that we talked about was, where's my colors? Nope. The next gland that we talked about was the pancreas, and its two chief hormones, insulin and glucagon. Insulin is responsible for lowering your blood sugar. It is triggered by a rise in your blood sugar levels. Insulin bonds to blood glucose, and it allows cells to take the sugar in their membranes out of this blood and into the cell membrane. It is produced by beta cells. Glucagon, on the other hand, is its counterpart. It is produced by alpha cells, and glucagon is triggered by low blood sugar levels. It functions to trigger the liver to convert glycogen into glucose, which allows sugar to become present in the bloodstream. So the pancreas produces these two hormones, which are responsible for maintaining blood sugar balance, either by raising or lowering the blood sugar. So if something goes wrong with the pancreas, you would imagine that what is going wrong is either the overproduction of something or the underproduction of something. This leads us into our discussion of diabetes. There are two types, type 1 and type 2. Type 1 diabetes is juvenile diabetes. It's often diagnosed in childhood. It becomes very apparent very early on that a kid is not able to regulate their blood sugar levels. They eat and then they crash out. They may have seizures. They may go into a coma. It becomes very, very apparent that a kid cannot do this very early on in life. This is why it is juvenile diabetes. We usually catch this around 3 or 4 years old. The issue is usually autoimmune. Their immune cells are attacking the beta cells in the islets of Langerhans. And when the beta cells are under attack, they cannot produce insulin. So they are not producing insulin due to an autoimmune attack. They require regular insulin monitoring and insulin supplements. On the other hand, type 2 diabetes is often called adult onset diabetes. This is the one that is a disease of lifestyle. It is most often diagnosed in adulthood. However, in the United States, we are seeing more and more cases of children and adolescents being diagnosed with type 2 diabetes, where it's becoming more and more common. The underlying issue here is an issue of lifestyle and pancreatic fatigue. The body has been subjected to so many carbohydrates, so much blood sugar. We've produced so much insulin that the body has become resistant to it, which just creates a positive feedback loop. Now we have to create even more insulin. So you become more resistant, so we create more insulin. Eventually, the insulin stops having an effect, and the person is then no longer able to regulate their blood sugar. Type 2 diabetics, when it gets to this stage, just like their type 1 counterparts, also have to begin pricking their fingers and monitoring their blood sugar and taking extra insulin. But type 2 diabetes can often be reversed through extreme diet and lifestyle changes. Type 1 diabetes, since it is autoimmune, there is no way to reverse it. There is no cure. Unfortunately, they will be pricking their finger and injecting themselves with insulin for the rest of their lives. This brought us into our conversation about the reproductive system. We started out with looking at the we're still in the endocrine system. Glands, gonads. Female gonads were called ovaries. The two hormones they produced were estrogen and progesterone. Estrogen was related to almost all female sexual characteristics, secondary sexual characteristics, and regulating menstrual cycles and pregnancy. Progesterone was more limited to regulating menstrual cycles and pregnancy. In men, the gonads are the testes. They are responsible for producing testosterone. We also looked at kidney endocrine function. The kidney produces 3 main hormones. These are erythropoietin, renin, and calcitriol. Erythropoietin increases the production of red blood cells, which will increase the body's ability to store oxygen in the blood, or increases blood oxygen levels. Renin increases blood pressure. Let's forget how that happens and just remember renin does blood pressure. And calcitriol, which is an activated form of vitamin D, it increases blood calcium levels by pulling calcium out of the bone matrix and depositing that calcium into the blood. The last gland we looked at was the thymus, which produces a hormone known as thymosin, which assists in the development of white blood cells. We also talked about the thymus's role in the immune system. We said this is one of the 2 main colleges where white blood cells go to school to learn how to do their job and develop their functions. They can either go away to the fancy Ivy League school in the thymus, or they stay close to home where they were created and go to school at the local community college. This is what forms the differentiation between B cells and T cells. B cells are called B cells because they matured into bone marrow. They stayed close to home where they were made. The cells that migrated to the thymus to mature are known as T cells. They take on different functions from their B cell counterparts. So it's a just nice, easy way to remember the difference between the two. B cells went to the college in bone marrow. They went to a community college. T cells went to an Ivy League school. They went away for college, but they get more specialized functions. Next, we turn our attention to the male reproductive system. We started out by understanding that the male genome is triggered by the presence of a Y chromosome. The default development process will generally result in a female child, It is only when the Y chromosome becomes expressed and begins producing testosterone that we then shift the plan to start producing a male child. We talked about the fun embryological changes that happen with the genitals and how that actually happens. That is not on the test. That is nothing important. I just thought you guys would enjoy hearing that story. That's not on the test. What we do need to know, males are XY.
I'm not. I'd love to.
Did someone come
Eric, you're
unmuted?
unmuted.
Thanks. So what we do need to remember is that males are XY. Male puberty begins usually between the ages of 9 and 14 years old. This chain of events, I want you guys to know, the hypothalamus produces a hormone called GnRH. GnRH is then picked up in the anterior pituitary. The anterior pituitary then produces luteinizing hormone and follicle stimulating hormone. Those are released into the bloodstream. At some point, these hormones will be carried to the testes. When the testes receive these two hormones, they will begin producing testosterone. Testosterone will trigger sperm production. Any questions? Okay, I want you guys to think about this now. Do we have any questions over anything related to the endocrine system? Any concept or idea that we want to revisit? The next quiz you guys have is over the entire endocrine system. So I want to make sure that we're good on this subject before we start taking that quiz.
I just have kind of a question about the diabetes part.
Sure.
Just because, so type 2 diabetes runs really heavy on both sides of my family, and I keep hearing that like the sensitivity in diabetic people is like less, so they don't feel as much, but everybody who I know who has it, they are like overly sensitive in like their feet and stuff like that. So I was just curious if you know what's up with that.
We generally start seeing that loss of sensitivity as the diabetes gets worse. So if your diabetes is managed through medication and you're taking your insulin like you're supposed to and all that stuff, you usually don't have to worry about those kinds of things. It's the people who aren't taking their insulin and they aren't monitoring their blood sugar and they just keep letting it get worse and worse and worse.
Okay, thanks.
Yeah, unfortunately, there are people, I mean, it sounds odd to be like, well, you've got a disease, why wouldn't you take the medicine for it? But like, for example, my father-in-law has diabetes and he lost his foot because he just wouldn't take care of himself. And now he's about to lose, they had to amputate above the ankle and they're about to have to amputate just above his knee because it's just getting worse and he's just not taking care of himself. And like,
oh my gosh,
what do? You know? I mean, he lives in Texas, so it's not like I can go down there and give him insulin myself, but yeah, the complications arise when people stop taking care of themselves. Yeah, so as long as they're taking their medicine like they're supposed to and all that stuff, you can usually stave off the worst, the worst symptoms of the disease. But I would also remind you that type 2 diabetes is lifestyle. Of course, people can be predisposed to it, of course, but oftentimes through diet and exercise, if we're able to lose weight and rebalance the muscle fat ratio, we can stabilize the endocrine system, and it works. I mean, I've seen plenty of people do it. So.
And just to clarify, only children or people younger than 18 or 21 can have type 1. No adults can have type 1.
Adults can have type 1.
Oh,
Remember
okay.
that it's an autoimmune disorder.
Yeah.
I'm chewing ice. It's an autoimmune disorder, and these can arise at any time. So we often diagnose them in childhood, but it is common for an adult not to have, they don't have diabetes until they do. And their immune system got triggered one day and started attacking those cells, and suddenly they were able to do it. So you can develop juvenile diabetes in adolescence or in adulthood. It's just more common that we spot it in kids.
Okay.
All right, good stuff, guys. No more questions? All right, my friends. Well, I know it's a little bit early today, but that is all I have, and I don't see the need to keep you here on this. Yeah, we'll call it a beautiful day. But that's it. So if you guys have questions, reach out to me. And before we break, though, I will remind you, check your grades on Moodle. If you are missing an assignment, there are several of you that are missing questions. Every week, you guys are supposed to go in there and answer questions. If I'm missing your questions, or some of you guys missed quizzes, if you're missing anything, get with me. If it's something that you're able to just submit it late, just submit it late. I won't take any points off. But if you need me to reopen a quiz or something for you, you need to get with me because we got to schedule that. Message me on Moodle or shoot me an email. Good stuff.
Thank you, Dave.
DH at Oregon School of Massage. I am DH at OregonSchoolOfMassage.com. Good stuff. If there's nothing else, you guys have a wonderful afternoon. I will see you next week. Same bat time, same bat channel.
Thank you.
Thank you. Bye.
Yeah, have a good night, guys.
Thanks. Bye.